Okay, this is question 4 of analytical geometry. First, we got to make sure we know exactly what we're dealing with. They give you the points F and G kind of makes a triangle here. They tell you that the vertices of the triangle are F, G, and C right on the outside. But here's an important one. FG is perpendicular to C. It's 90 degrees. 90 degrees, so we know what that does for gradients, and that's important. And it's a point on FG that the angle of inclination, this is 104.04 degrees right here. And they named two angles here, beta and theta. So we're going to look at those later too. Let's try the first question. Calculate the gradient of FG. Calculate the gradient of FG, that's 4.1. Well, there's F and G. That's a pretty easy one. 2 minus 2, 2 plus 2 over 5 minus 2. I did this quickly and I made a goofy mistake here. Ooh, how goofy, because 5 minus 2 is 3. So there's the gradient, 4 over 3. What's the value of y? Well, I don't know what y is, but this FC is connected, this line here. I know that it's perpendicular to FG because they told me it was. That means the gradient of this line FC must be 4 over 3 turned upside down and negative. So the gradient of FC is minus 3 over 4. I got to turn it upside down and change the sign. They've got to multiply to equal -1. That's what perpendicular gradients do. Then I just use the gradient formula. I go y minus 2 is y plus 2. I go 6 minus 2. There it is. That's the gradient of FC. And if I solve for this, I'll get y. Well, this isn't too hard. 6 minus 2 is 4. Then I multiply by 4. It cancels here. I multiply by 4 here, and it cancels there. So I just get minus 3 equals y plus 2. Looks like y. If I subtract 2, y is minus 5. Maybe we can do the rest of this all in one video. We did that pretty quick. Calculate the size of theta. 4.3, the size of theta. Well, we know the gradient of FG. They told us it was 4 over 3. 4 over 3. Now, if you go shift tan of 4 over 3 of this gradient, you get beta, the angle of inclination. That's what it's all about. So you go shift tan of 4 over 3. Hey, I figured out something real important. That's 53.13 degrees in my calculator. Now, these two angles here, they add up to the exterior angle, this one out here. There's other ways you can do it, angles in a line and then angles in a triangle, but the easiest thing is just to go 104 minus 53.13. Theta must be 50.91 because beta and theta have to add together to make 104.04. So that's why theta is 50.91. Now the next question is pretty tricky because you're doing this analytical geometry and all of a sudden they ask you a question. You could probably do it other ways, but trigonometry is the easiest way. I've got a right-angled triangle. I know the angle theta. If I could figure out this side FC, I can answer this question. How long is NC? Well, if that's what I did, I worked out the length of FC. And so I subtract the x coordinates and y coordinates and square them and take the square root. And oh, FC was something nice. It was 5. So this is 5 units. So this is opposite theta. This is a right angle triangle. So the opposite over the hypotenuse is what they're looking for. NC, that is the sine of 50.91 degrees. Then they just trade places. You multiply by NC and divide by 50.91, and you get your answer. NC is 6.44 units. And that's the whole thing done. You know, I looked at it other ways too. I thought, gee, I could get the gradient of this line, you know. Maybe I've got a point here. Maybe I could get it in. I thought about it different ways when I first looked at it. And I went, oh, no, that's trigonometry would be the easiest way to do it. And I think that's the way it's done in the government memo you can see as well. So there you go, question 4, all done.